All right, y'all. So this is a little Google Slides that I put together to kind of detail some of the things that I thought needed to be detailed, and ultimately kind of put us all at the same understanding, so we can get a really good grade on this on the oral portion of this final, at least. I apologize for this being so slow. I got a life and I got things outside this class going on, but we're here now, and hopefully I'll try my best to make this video short and as concise as possible. So it's just not a big, like a very long video I'm having you on watch. But do give me a little bit of wiggle room because I haven't kind of practiced what I'm gonna say for this. So it might be a little unconcise at points, but we'll get there. So let's do it. Without further ado, let's go right ahead into the slides. And I'll move this around for y'all. Whoopsie daisy. So let's talk about Lobby's data first. That's the first thing that I think we need to talk about. So the two most important things about his data is that he performed a two-tailed t-test, and this was also a paired t-test. So what a two-tailed t-test means is that when we are looking at looking at how like sleep deprivation or sleep in general kind of affects reaction time, to be confident in our data, we wanted to see if there's a significant difference below, like well below the mean or well above the mean. Basically, in the perfect world, we want to be 95% accurate or 95% certain that the difference that we found was either right here or right here. If we looked at just making sure 95%, or if we want to be really accurate and have 95% confidence, we could say, basically, since it's a two-tailed test, we looked at both sides, not it being extremely low or extremely high. We looked at both. I don't know if that sounded good, but definitely feel free if y'all have more questions to ask me. Or first, you can do your own research, but next you can either ask me or ask Dr. Brian. But yeah, that's a two-tailed t-test. We looked to be confident in our data. We looked at well below the mean and well above the mean. Next, I have here a paired t-test. That's what another part of his test. Basically, what a paired t-test is that we did two different variables to the same group of data. So when Lobby went out, he recorded 10 different people and how they reacted to being sleep deprived and being well rested. So since we used the same 10 people for both of those things, that's called a paired t-test. Next, I have detailed a R value, or like the word, I have detailed what R value means. R value and correlation coefficient are the same thing. So basically what R value is a statistical expression of the relationship between two variables. I don't have a lot of this planned out. I tried to minimize as much as I could, but I might go back and forth a few times, so excuse my camera and everything. But when we look at R value, and when we talked about it in the class, to be very confident in our data and to say that there is some type of relationship, we basically wanted R to be very, very high, like between 0.8 and 1.0. But we can see that our R is less than 0.20. So based off of our data, we can say that there is a very weak relationship in our data. Almost, from what we calculated, there was almost zero correlation. This R value can either be positive or negative as well. So it is positive. We detailed a very small portion of positive relationship. But in general, the main takeaway here is that there was a very, very weak correlation between our relationship. Because very weak starts at being an R of 0.20, and we have a R of 0.02. So almost we can say zero correlation. So yeah, big takeaway is that there was an extremely weak positive correlation in our data. Next thing I wanted to detail is going to be correlation coefficient. Excuse me. Next thing we want to talk about is coefficient of determination, or R squared. The R squared that we calculated from our data is going to be 0.0005. But the main thing about this number, and we see how small it is, basically it just means that our data didn't have a lot of proved kind of scientific correlation. I have some examples here that you can, or some things that I kind of took from, all this came from the book, and my book is on Chegg. But basically, let's take a look at this for a second. So this is R squared. So if we square the correlation coefficient, which is this number right here, we get the coefficient of determination, or R squared. One quick pause I'll do is that when you ask about how we statistically analyzed our data, these are going to be the two main ways. We looked at correlation coefficient, R value, and we looked at coefficient of determination, R squared. I want everybody to understand that. So if you're a note type person, if you're taking notes, definitely write that down. That's some of the biggest understanding of our data. That's how we statistically analyzed it. So the coefficient of determination tells us the amount of variability in one variable. this explained by the other variable. So this sounds confusing at first, but think of a chart. Think of a chart that has an X and a Y. So basically what we did is we defined an X and our X. Let me click a couple tabs. Whoopsie daisy, where'd it go? Oh, here we go. Our X is going to be the reaction time in centimeters while having adequate sleep. That's our X value. And then Y, being a predictor value, is going to be what the variable that is explained. So our X variable, our X variable is going to be reaction time while well rested. Our Y and the variable that gets explained is what do we think would happen when when we decreased our sleep. That's going to be our X and Y. So then I have a little example for y'all to look at right here. This is straight from the book, so maybe y'all can find that. In this example, I kind of have it cut off here. I'm apologize about that. Basically, their R squared, their correlation coefficient, when they squared this number right here, they got 81%. So this says basically that 81%, or for us, let's just stick with our 0.0005%. Basically, you can say right here, based off of that number, about 0.05% of the variability in the distance dropped without adequate sleep, Y, is explained by the distance dropped with adequate sleep, X. So basically, we can only say, based off of our test and our design, that less than 1% of our Y can be explained by our X. That's the main takeaway. If there's a sentence to take away, it's that one. Less than 1% of the variability in our reaction time without adequate sleep, Y, is explained by the distance drop with adequate sleep, X. That's why I highlighted it. Everything highlighted on this slide, especially, is going to be the main takeaways. So the other part of that, the other part that's very important, is that 99.95% of the data that we calculated is attributable to factors outside. Basically, let me not try to read it verbatim and say based off of my wording. Basically, we can say that almost 100% of our data is attributable to chance alone. So basically, like 99.95% of our data is luck, but our test design wasn't very good, basically, which is perfectly fine. I want y'all to understand that us having a bad test design is perfectly okay. But we can say, with a very low R squared, 0.05, that nearly 100% of our data could be attributable to bad factors, essentially. Once again, I apologize for not being the most concise, but I think y'all get the general message. Anyway. So this is just going to be some of that stuff this is going to be Lobby's graph. Ultimately, I want y'all to see how this is our X right here, time with adequate sleep. More so less than reaction time. This is kind of more of our, this is going to be more of our centimeters drop. We kind of got rid of reaction time a little bit and more so looked at centimeters drop, which is perfectly fine. So this is our X value. This is our Y value. And then I can show y'all a graph based off of that. So when you graph all of our X values, that's going to be while receiving adequate sleep, this row or column or whatever. And then when you graph the Y values, the predicted value, this is what that graph looks like. And let's see what I have written down here. Big takeaway is that we use the t-test to see if there is a correlation between our two variables. Oh, my fault. I didn't know my camera was in the way. Okay. And since trend line, this blue line right here, that's called a trend line. Since the line is almost completely flat, basically it showed a low correlation, almost zero correlation in the two things that we identified. And that's, once again, that's perfectly fine. That's just what we came up with, and that's what I want y'all to be at an understanding of. And let's do this. I'll move this. So this part is more specific to KK, but at this point in the project, I want all of y'all to listen to everything so it can be a very smooth and cohesive presentation whenever we do it. So me and KK, we kind of talked about how to add graphs or what the graph might look like that we need to add to the final project, or to the just basically to that little final one-page thing that she has us do. Although I don't know how to do it yet, a big takeaway, whoopsie daisy, is that the X value needs to be sleep calculated while having adequate sleep. So all those, basically just like this here, we need to put this in our X column and then this in our Y column, and then kind of draw the graph, and then if we can, put a trend line on it. But more importantly, even if we can't find out how to put a trend line on it, know that the trend line is very flat, meaning that there's almost no correlation between our data. So this is back to everybody. KK needs our help, essentially. Let me move my camera one more time. KK definitely needs our help because we don't know how to set up this final little piece right here. And although KK can figure out how to set it up, she basically doesn't want to put down what you need to be saying. And I know even if she were to do that, like it would just be better if like you could help her formulate this and make sure that this portion is what you want to say, but in short, like a very condensed version of everything that you want to say. KK needs everybody's help with doing that. I kind of tried to start doing it and seeing what it would look like right here. But everybody kind of has their own section. And this is kind of what the final is going to look like. Just like the other group's presentation that we looked at the other day. So this next section is going to be less about, it's going to be less about what we need to know from our data and more about how I see like the presentation flowing, like who needs to speak in what order, and mainly what I feel like needs to be said. Although I think what I think needs to be said is very like good, and like I think this would get us like nearing a 100 if we said everything the right way and understood what we're saying. Definitely feel free if you think something else should be added or if something should be taken away, because I'm definitely open to that. I think that's what I really like about our group. We're open to listening to each other, and I definitely value y'all's opinion just as much as I value mine. So if you do think something should be changed, definitely let me know. So we got Caitlin going up first, and I think Caitlin will talk about our abstract. So right here, Caitlin, I have for you the main takeaways from the abstract, and this is what she had detailed in Cougar View. So the abstract needs to have a little bit of a background, the methods we use, the results from this in short, and like a little conclusion. So I have those things kind of detailed right here. So our background, and she has, why did we do this research? The main thing, or the main reason why I think we chose to do this research is that it's a relatively easier test, especially when you look at some of the other groups and they did all this crazy arm flexion. We chose to do this basically because we had access to a lot of student athletes, and we did a test that would be relatively easier to do. Even though we kind of went into it knowing that our data wouldn't be great, we knew that this would be an easier test to do and something that we could look at and understand how to kind of analyze our data from that. 2 would be methods. So methods would be we administered a ruler drop test to I have student athletes right here, but I want y'all to delete that because I think the plan was to do student athletes at the beginning, but it turns out that 7 of them were student athletes, and then we had to do 3 people that weren't student athletes, which is perfectly fine. But yeah, definitely get rid of that part. So yeah, we looked at how their reaction time kind of changed when they were well rested and when they were sleep deprived. And we did this using a paired t-test. So 3 would be the results. What did you find after doing the research? The research that what did you find out after doing the research? And I think I did kind of mainly focus on this part. Doing research, we kind of concluded that as you got more sleep deprived, or as the ruler kind of dropped further, as you were basically the less sleep you had, the further the ruler would drop and the slower reaction time would be. Go back and watch that, or re-listen to that sentence, because that's a very good sentence. I think I worded it really good there. Conclusion. So our conclusion is all written out right here, and this conclusion is like the biggest part. So when we did the test in our own, like when we created our test and did it, we calculated a low correlation coefficient, which we already talked about, and a low correlation or coefficient of determination. So our data shows almost 0 correlation between reaction time and kind of sleep deprivation. I think I missed that part right there. Another big conclusion, although that is literally what our data says, another big conclusion is that we concluded that it is very difficult to create and perform an objective, reliable, and valid test. That's like very important. Everybody should know that part. The whole point of this, and the whole reason why we did this, is to see how difficult it is to create objective, reliable, and valid test. So as long as you say these things, Caitlin, I think we'll be good to go. Let's see what we got next. So next is going to be Hannah's background. And And once I'll say this real quick too, Caitlin, you did have a really good. I saw what you sent me. It was really good. It was actually a part of this same thing. But I just wanted to kind of narrow down the parts that I think are most important. Kind of take out what someone could define as fluff and kind of just leave it as all what we need to be saying. Which you, once again, did a very good job with that. That was just how I would narrow it down. If you think things should be added or taken out, definitely let me know. So Hannah, this is your portion on background. I read this multiple hours ago, and basically I thought it was really, really good. And I think everyone else who didn't have anything to do with writing this should definitely pause or read this whole thing right here and see what you think of the background. I think this background was really, really good. There are some things that I would take out that we can talk about one-on-one. But as long as you kind of detail some of the, like, if you detail all this stuff, I think this is all really good and will get us a very good grade if, as far as the background section goes alone. Let me move this right here. So next I have Lana talking about the methods. So once again, I feel like everybody should pause this and try and just read what the original test that Lana had was. And this was the method. This was originally like how we were going to do the ruler drop test. So definitely feel free to read that. Lana, as far as your part of the presentation goes, I do want you to not read this verbatim, but I want you to have a very good understanding of how our test was to be administered, at least based off of the research that you calculated, or the research that you did, excuse me. A lot of this, and I even want you to talk about this part right here. Ultimately, we did end up kind of getting rid of this section, but I want you to talk about it just to show that you did a lot of research, that you got an understanding of what your research meant, and all that stuff, and so on and so forth, just to prove that you worked really hard on this, because I know you did. But we want Dr. Brian to know that too. I believe I said everything here, but if you got any questions, be sure to let me know. So next we got, I think it would be make a lot of sense to have Reek the recruiter talk. So let's see. Here we want Reek to talk about the 10 people that you, or just in general, what Reek did was test the 10 people. The parts that I think you should say is that 7 of these people were student athletes and 3 were not. That's very important. I want you to also talk about how many of these people were guys and girls. Another thing you can talk about is what sports they do. That's a very good, big one, because ultimately we want to say that different sports may affect how you react a little bit differently, like your reaction time, I mean to say. And the average, you can also add in like the average age of all the people who did the test. Basically anything you want to say about the people who conducted the test, I feel like you should say, to once again prove how hard you worked and that you had a very good understanding of everything that you did. Now, this is something that I do want you to say. I want you to use this word summative formation. So basically what I have written down here is that we came to a summative formation that we didn't need to convert centimeters dropped to the actual reaction speed, essentially. Just like I told y'all a second ago. Actually I have it right here. I'm sorry. The main point of our test is to talk about how reaction time is affected by sleep deprivation. So we didn't convert centimeters to time, like how long it took for the ruler to drop. We just kind of left it at centimeters, which is perfectly fine. I just want you to say that we came, that we came to a summative formation that we didn't need to convert centimeters drop to actual like reaction, like a time. Instead, we just left it as centimeters drop. And I think that's what this says here, or that's what this says here. And once again, I think I said this already, just detail the test, your process, what we did, what we changed about Lana's research, or the things that we took out, the things that we added. Basically, I do want it to sound like our test was bad, because ultimately it was, which don't think there's a problem with that. Bad test or bad test design is like a whole part of this course. We want to show that it is very difficult to across 8 different people to like keep the same idea in plan or in motion. So yeah, that's your section. That's that. So next I got the analyst, which is Lobby. I already talked about a lot of his stuff to begin this. But this is what you actually need to say this time rather than just looking at the data as a whole. So Lobby, you calculated a paired and two-tailed t-test in Google Sheets. I want you to say that. And then I want you to say, basically define what a paired t-test is and what a two-tailed test is. Once again, a paired t-test means that the same 10 athletes were used for 2 different variables. And those 2 variables were adequate sleep versus sleep deprivation. two-tailed t-test on a normal curve, we looked for any difference between our data that was higher, like extremely higher than the mean, or extremely lower than the mean. One-tailed test, like I said earlier, is just the one direction of the data. So if we wanted to say, or if we wanted to try to test to see if, like, oh, I think the data is going to be only higher than the mean, that's called a one-tailed test, or only lower than the test. That's still a one-tailed test. We did two tails. We looked at both tails to see if there was a difference, regardless if the difference was higher or lower. Another thing I want you to say is that the t-test, from the t-test, we got the correlation coefficient, which is still this 0.002, which I want you to say it showed an extremely low correlation between our data. And then another thing that we got from the t-test was the coefficient of determination, which, or r squared, same thing, and this is the number we got from that. And once again, just detailing what all this stuff actually means. And I want you to actually be at a very, very good understanding of what this actually means. So R squared means that 0.05% of the variability and distance drop without adequate sleep Y, or which is the Y value, is explained by the distance drop with adequate sleep, which is X value. I think I misspelled something or didn't do something right. Basically, the X value is adequate sleep and the Y value is inadequate sleep. Okay, and I do think I said that right. So the other 99.95% of the data is attributable and other factors that affected the results we got for the distance dropped with adequate sleep. So 99.95% of the error that we got ultimately is just attributable to the definition of our X value being kind of bad. Let's go to the next one. And this kind of just looked at two-tailed test again. I already explained it. Two-tailed test is that we look for a difference extremely above the mean or extremely below the mean. When there is a difference there, and when we're 99% confident that there's a difference that lies either here or here, that means we can statistically prove our point, or reinforce, or say that our test was statistically proved. But ultimately our test wasn't, because our data didn't lie well above the mean or way below the mean. Matter of fact, our data lied almost right at zero, saying there was like no correlation. That's kind of what that means for us. So next is going to be the reviewer, which is Amber's section. Let me move my camera. Basically, this is everything that Amber sent me. So you can feel free to pause this and read this and let the group and Amber know where you think changes should be made. I kind of looked at it earlier, and let me let my mouse be seen. Whoopsie daisy. I looked at it earlier. You can see some of the notes I said here about it. But yeah, these are some of the changes that I felt like should be made. It's been a while since I've looked at this, so I don't remember what I was saying. But definitely form your own opinion on that. And if you think there's a change that should be made, definitely let it be known. So this is what I think you should say, Amber. I do think you should say, now this part I think is fine if you read verbatim. Of course, it would be better if you remembered it or came to a really good understanding of it, just to the point where you could say it without reading it. But I think it was so good that if you say your discussion part as a whole, that's what we need. Like that's just what we're looking for, essentially. So the discussion part that I said should be read as a whole should be this portion right here. And once again, I'm completely fine if you read that verbatim from your phone. I don't want you to read it from a slide, and we don't even have enough space on the board for it to be up there. But if you have it on your phone, you should say all of this, although I did make this one adjustment to it. Once again, I forgot what that was, but if you have any questions, be sure to ask me. But yeah, I think this discussion section should be read verbatim. Next is going to be everything else, which is objectivity, reliability, and validity. So Amber, I still want you to come up with, or you don't even have to come up with on your own. I just want you to give at least 2 examples of how we could have increased each one of these variables, or one of these things: objectivity, reliability, and validity. Because ultimately our test was really bad, which once again is fine. But I want you to just think about ways, or ask me or any of our group members. I want you to ask us ways that we think our test could have been better. And then I just want you to say that to the class and to Dr. Bryan. So we understand, so we're at an understanding of how we could have made, or how this test in theory could have been just really good or better. I do some of the things that I think should be mentioned without a doubt is these 2 bullet points right here, or stars. I want you to mention how if we worked with a bigger sample size, it would have increased our test validity. Basically, when I took stats in high school, they told us we can only like statistically analyze data when there was 30 or more samples at play, or 30 or more things being tested at once. Because there's just a lot of bias when we do a number lower than that. So know that I want you to say that if we increase sample size, everything about validity, so increasing objectivity and reliability, everything would have went up if sample size was bigger. I want you to say that. Maybe you can say that just in increasing validity in general. Next thing I want you to do is mention how our criterion for us, which is going to be the X value, I want you to say how X value could have been calculated better. Basically, and I have another way to phrase it right here. I'm trying to think of another way to word it in my mind. How could we have determined reaction time while rested, our X value, better to predict our reaction time while sleep deprived? So basically, how could we have made our X value more like to a better criterion, or to the criterion of how could we have just made the X value closer to a criterion? Something to think about is that we use this one way of measuring reaction time. There's whole other tests for testing reaction time out there. There's tests on the computer that you could say are more valid. There's just all different types of other tests out there. So I want you to speak about what we could have changed about measuring that X value to make it closer to a criterion, or to like the main way to measure something, if that makes sense. Use the word criterion. Using all these words like criterion and the summative formation. Those are words just to prove that, we actually took something away from this class, because these are words that we in class we described like before we got to this final section. And lastly is going to be me and KK. What I'll tell the class is just different ways to interpret our data. So I will say the main ways, and once again, the main ways that we looked at our data was correlation coefficient and coefficient of determination. Those are the two main, like if she asked what statistical analysis we use, that was the two we looked at. But there's also other statistical analysis to look at that probably every other group did. Although we didn't use it, which is fine. But I have it described here so we can talk about, just so we can discuss it in class. And maybe it'll make your understanding a little bit better too. So this is the part I plan on doing. Basically, I want to show how we had a super low p-value. So that means our confidence was very low. If p-value is low, confidence level is low. Those things, there's a direct correlation there. So what I did was I found a t-table, and this t-table was the same. Like this t-table holds the same information, no matter where you find it on the internet. Oops, I didn't even know my camera was in the way. So let's talk about the t-table. Basically, when you calculate a t-value, which Lobby ultimately did in his test too, we get a t-value of 0.074. And we know that the degree of freedom in our test was 9, because degree of freedom is like number of people used to do the test, which is 10 minus 1. So 10 minus 1 is 9, and our degrees of freedom is 9. So in this table, we're going to start with 9, because that's degrees of freedom. That's what this column is, DF right here. We go to 9, and we try to find where our number is, 0.074. And let's actually get rid of the 0.074 first. If we wanted to be 95% confident in our data with 9 degrees of freedom, I believe that's this one right here. Our T would have had to be 0.074. Or excuse me, our T would have had to be 2.262. But we obviously see with 9 degrees of freedom that our T value was 0.074. So we go to 9 degrees of freedom, try to find 0.074, and we're stopped right at the gate of 50% confidence, because our value is way, way, way lower than 0.703. And matter of fact, it's way closer to 0. Whoopsie daisy. So this proves, since our test is really close to 0, this 9 degrees of freedom, that means we have almost 0, like just a little bit higher than 0% confidence in our test ultimately, which is perfectly fine, like I said. So this is a main way, because you want to be 95% confident, right? And our test is almost 0% confident. Perfectly fine, but we're at an understanding, and we can explain why it is at like a 0 or close to a 0% confidence. Wrapping up, we got KK, and what she's going to talk about is some of the big takeaways from the project. Some of the things that I have, KK, you can definitely feel free to add. Like this is where I think a lot is to be added and taken away. But these are two big things that I feel like should be taken away. One is the importance of teamwork in general, but you can talk. I think it would be better if we talk specifically about the field of kinesiology. I don't know if you guys have gotten the opportunity to shadow physical therapists, occupational therapists, ADs, or athletic trainers. I mean, all those people. It's a team. It's an army for sure. And if you can't work well in a team there, or if you can't work well in a team here, then like how would you ever imagine to work well in a team in the field of kinesiology? Whether you in the field of kinesiology. Once again, just to try to summarize it in one sentence, we had a lot of very, very good teamwork. Whenever I asked them, for example, whenever I asked somebody to do something, they were right there on it. They got to me as quick as they could. Their information was very good. We had a lot of very good teamwork. And if you can have very good teamwork here, then teamwork in your field of work will be, there's a correlation there, basically what I'm trying to say. If you can work well in a team here, then you'll definitely work well in a team in whatever your field of kinesiology is. Because ultimately, this is a kinesiology class. And ultimately, a lot of us do want to be like PTs and OTs. So just definitely, I want you to talk about that correlation between teamwork here and how teamwork will affect all of us in the field of kinesiology. Second biggest thing is that I want you to say that it is very difficult to make a objective, reliable, and valid test. That might be the single biggest takeaway from this class. And that's what our data showed. We did all this data and did all this research just to say that there's almost zero correlation in what we did. Sounds goofy, but once again, that's the whole point. You can definitely feel free to add more here, but I definitely want you to at least talk about those two, KK. And that wraps up our final. Everybody got a chance to talk. If you had any problems with that, definitely be sure to let me know there. So this is just my final remarks to y'all. Basically, I looked at all the stuff that we did and made sure that it followed within the guidelines of getting an A, which is going to be this sophisticated kind of category. And this is just what we need. And definitely pause this. Feel free to read this right here. But these are kind of my main takeaways of how we're going to get a 100, or how I believe we should definitely get a 100. This is what we need to do to ensure that we get that 100. Basically, our first things first, no negative remarks about each other. That falls into the teamwork category. If you read this, using my own words, is saying that we worked well together and we didn't want to have any negative remarks about each other. The last group who went, whatever the day of the week it was, they probably got very low on here because their admin was dissing, or like he did speak on a lot of good, but he emphasized a lot on the bad, which I think would knock him down from this category. So that, like, in general, I think we worked better as a team than other teams because we did a really an easier test than most of them did. So there's just less things to get frustrated with. But in general, just no negative remarks about each other, so we can show that there was very good and a lot of teamwork right there. Another thing is to go to this contribution section, and once again, I want us to be here, and I think we will be here. But to make sure we're here, I want everybody, whenever you talk, to explain what was difficult about your portion and to show that you put in an extreme amount of effort to aim for and to get valid, reliable, and objective data. I want you to go in detail about the struggles that you went with the research you did, the struggles that you did, or that you went through in setting up the final presentation, the struggles that you went through with just everything. Any struggles you went through, be sure to detail them ultimately, and that'll show that you tried very hard, just like I know we all did, and it'll put us in this category right here. Last one, this is just the content portion. The whole idea for me doing this, I think we're at 35-minute video, is that basically I know that we have the content. I've looked at everything and I'm putting us all at this understanding, so we do all understand that we have all the content, all of the data, and we analyzed all the data to make sure that we can get 100, not only in this section, but 100 overall in this whole project. So the whole idea is that let's prove that we deserve to be here. Reread all these things if you haven't already, and tell me if you think there's things that we can change to make sure that we are here. Let me know, let the group know, because all of our grade is kind of in the air with this one. And I do think if we follow what I've outlined, then we'll be here. But if you think there are ways to make it better, please feel free. Last thing, we dressing up. even if it's not detailed, I do think this was detailed in Cougar View, or she said that we should dress up in general. It just gives us a better look, and it shows that we put in a lot of effort, and that we want to show that we know what we're talking about. So we're definitely going to dress up. I like the idea of coordinating how we dressed up, just to show that we work as a team very good. So if y'all watch this and y'all think like, oh, y'all got a black shirt / dress, and all y'all got black shoes, hey, let's do it. But yeah, these are just all things, my final remarks, and how we're going to make an A on this project. And there's no more right. I can't click to the right anymore. So that's everything I have for y'all. I apologize for this being 35 minutes, but I do think this is important. At 35 minutes of very important information. If you have any questions, be sure to let me know. I do think we should also plan on meeting if we still can, just to make sure everything's in the clear. But I do feel like we're all under the same, we all know the same things now. My administrating of this is over, because we're all at the same understanding, and we all know that we should make a 100 on this. So I'll let y'all get back to what y'all are doing. Thank y'all for working with me. Thank y'all for putting me at this admin position. Thank you for listening to this video, and just thanks for everything. I hope all y'all find success in y'all's other classes, but y'all gave me the opportunity to make sure we succeed in this, and I definitely didn't take that lightly. So thank y'all, and I guess I'll be seeing y'all soon.